Hello everyone, January 19th. Alright. First thing is it was a bad day today because, well, I shouldn't say a bad day, but I was trying to just continue working on what I started yesterday, the extreme gradient boost tree, trying to use that on my research. And then you know what happened? I was trying to tune it, right? And then I was tuning it, I was getting very detailed on the response, and I found out two very interesting things happened. Okay, number one, I was tuning different parameters for different data sets, and then the results are exactly the same. I mean, this is not right. They shouldn't be the same because the two data sets are very different. So they shouldn't be the same, but they are the same. So yeah, something is wrong there. But more importantly, if I tune those parameters individually, one took about 40 seconds, the other took like 35 seconds. So I'm thinking, okay, if I tune them together, it should only take a little bit over 1 minute, right? Not even 1.5 minutes. And what happens is it took 3 minutes to tune them together. So I was like, what the hell? It didn't make any sense. And then you kind of just dig deeper, and I run some, my debugging session, a lot of print. And you know what happened? This happened. I'm gonna just put it right here. Python default argument mutable. Mutable default argument. This is the pitfall that I got into. What it means, if you pass in as default argument something mutable, and then you mute it in it, and if you call the function multiple times, this default argument does not get refreshed each time you call the function. So if I call the function once, it creates a new object, this list assigned to the default argument. And if you call it again, it will use the exact same same variable that you have already created. Therefore, when you do this, right, when you do this call, you're supposed to think, okay, I am just going to get a new thing, right, a new default argument. But in reality, what this is happening, you get the first one is right, but the second one, it reuses the same object from the previous one, so you just append to it. And I was doing exactly this in all of my tuning, all of it. And I checked the hyperparameter that I tuned before. Yeah, I never really paid attention, but all of them are the same. So I was using the wrong hyperparameter. I mean, it's correct for one of the data sets, but it's wrong for the other data sets. Have been using it for since last December, and more heavily used for the past 2 weeks, and I never realized it. And today is the first time I find out the problem. And on Stack Overflow is actually quite interesting. There's a big debate on whether this is a design flaw from Python itself. I mean, the reason that it's this way is because everything is a class. Function is a first class object. It's a class, right? It looks like a function. I mean, the syntax looks like a function, but it's actually not a function. It's just an object. It's a class, right? And it has its name. And every time you use this def, you call this, you're actually instantiate a function class, which has a name like this one, append to, and then this is like the argument you have to supply, but this is basically just a default argument. It's a member, a field in the class. So if you define a function, you create this function class, and you supply something to its member, and there's no doubt that if you call the function again, basically just apply the object again. Why would a class recreate a new thing for its field? It's already filled, so you're constantly using the same thing. So it doesn't it's not strange, right? This is exactly how I mean, is this a gotcha? Yes, definitely it's a gotcha. But I won't go so far to say this is a design flaw. This is just something that you should know, right? I've been using Python for since 2019. I mean, maybe a little bit earlier, 2018, a little bit, many years, and I never. Well, actually, I took it back. I cannot say I never had this issue. I am very, very sure somewhere in my old ancient code, I have made the same problem before. I definitely have made the same problem before. But it never showed up because I guess most of the times I don't modify, I don't I mean, if you don't modify the immutable things inside, I guess it's fine. Yeah, it's fine. But it's just, it's a time bomb waiting to happen. And they do say this is the pattern that you should do. That's guaranteed that every time you call the function, a new immutable object will be assigned. So yeah, that's good. But on the other hand, thinking back, right, the design of a function, when you're writing it, why are you modifying this one, right? It's just sometimes you start coding and you get comfortable with it and you forgot the principles of functions. It has to be pure, right? Nothing inside the function should affect the things on the outside, and nothing on the outside should affect the function on the inside. Well, there are exceptions, and I'm using a lot of exceptions to this in my tuning because sometimes a little bit global variable really helps things smooth along, but if you can help it, you shall help it. So this is definitely the way to go, because if you give this function signature, right, if element is also immutable, then both are immutable. You know that nothing will get immune will get changed. Yeah, mutable things is the worst of the worst. I mean, I had a deep revelation about this in my internship, but sometimes you think if you write your code yourself, you can always avoid it, right? Because you know what you're doing, but now you don't. You run into this problem and then you just waste time. You waste so much of your time. I mean, it's not like everything I've done is gone. I mean, I just have to wait for 4 hours, I think. All the tuning that I need to do, it took about 4 hours. I think I'm already like 2 hours in, 2 more hours to go. I won't be able to get all the tuning done before I go to bed. And if something goes wrong, I'll fix it and then run it overnight. All right, so that's basically what happened today. And then the laptop is running at 100% right now. What is this today? Non-decreasing subsequences. Given an integer array nums, return all the different possible non-decreasing subsequences of the given array with at least 2 elements. You may return the answer in any order. I think I've done this before. 491, maybe I've done this before. So non-decreasing subsequence, right? So you can pick and choose. Okay. So let me get my pencil now. I have to hide my pencil from my cat. So the subsequence, it must start something, right? It must start somewhere. So if we're given 4, 6, 7, 7, I can say I want to find all the subsequences that start with 4, right? And then I say I want to find all the subsequences that start with 6, and all the subsequences that start with 7, and all the subsequences that starts with 7. Well, it has to be 2, so yeah, that's a good question. Does 4, 6, 7 appears once or twice? I think it's unique. Different possible non-decreasing a given with at least 2. So I cannot do 4, 6, 7 and 4, 6, 7 again, right? That is not possible. Okay, that is not possible. Yeah, that's fine. So we're gonna find everything start with 4, right? And then I can go say everything that starts with 6, anything from start with 7, right? So yeah, to find everything that starts with 4, we have to find everything else down. So I think it should go from right to left. So we could start from this one. Everything start with this. That's just 7, 7. Or not, right? Okay, we got 7, 7. Now everything start with this. So start with 6. I need to find everything starts with this 7 and everything start with this 7. Well, I mean everything that start with this 7 is nothing. So we can figure out all the 2's, right? We just go one by one. So we find, okay, 6, 7. That's a good one. So we have 6, 7. And from this 7 we have 7, 7. So we have 6, 7, 7. Okay, so we have 2. And then that's it. And we go to this, we have 7, but 6, 7 we already have it. Ooh, you're telling me we have to use a set to handle this? Like, how do you know we've already done it? Well, if you have seen this already, then you can say that we shouldn't do it again. I mean, everything inside this will be unique, right? Interesting question. Yeah, I guess, right? If I hit this value already, then I don't do it again. If I've done it already, if it's appeared already, then and itself will be an empty, and then we check, and then we will add to it. Okay. I mean, the length is 15, so maybe it'll be just easier we use a set, so we can avoid all this headache. Or maybe not. Is that the only thing that will have a duplicate? Yeah, I think that's the only thing that will have a duplicate, because for the 6 I'm already done, right? Now we go hit them 4. So 4 will look at 6. It's the first time we handle 6, right? So we have 4, 6. And then in 6 we have 4, 6, 7, right? 4, 6, 7, 7. And that's all for 6. Now we go to 7. Now for the 7, it's the first time that we hit 7. So we say 4, 7. And inside 7 we have 4, 7, 7. That's it. And now we go to the next 7. And in this 7 we already hit it. So we just look into what it has. And it doesn't have anything. So in total we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I think this shall be it. 2023. Oh my god, how slow can you be? The answer is as slow as you can imagine. Yeah, we have to deal with 2, 4, 6, 3 again. But we have the wrong cases, so that will help. Okay, so what we think is this one will be a we can have a DP. All right, well, DP, let's do a dictionary. So default dict, okay? Default dict with a list. We'll make it easier. And then we're gonna say for I in range len nums -1 -1, okay? Well, actually no, it's not okay. Let's just say dp nums -1. Oh, that's fine. We don't need this. We should go from this one, right? Because the last one still doesn't count. And then we just say this. We just go to the next one. We're gonna go one by one, right? And then for each one, well, we're gonna say scene is gonna be a set, okay? For j in range I plus 1 to the end, okay? If nums j is not in scene.add nums j, and then if nums j is bigger or equal to nums I, if that's the case, we can add by itself, which just say dp dot append, right, nums I nums j, okay? That's that. If it has seen it, then we don't do it. We just say for sequence in, oh, and also if, right, if nums j is larger or equal to nums I, then for sequence in dp nums j, right, we're gonna say dp dot dp nums I, dp nums I dot append this plus sequence nums I, right? Once we're done, blah 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 blah, we all done, we go move on to the next one, and then we'll return for v in dp dot values. Oh, just list dp dot values. Let's give this a shot. Okay, what do we have here? Nums. Find subsequences nums. Alright, after we do this, the rest.sort, answer.sort, and we'll run. Holy crap. What happened? Why is it infinite? I don't know. It's a list, so what? Oh, I know why. Man, it's a bad day to do this. I think it's because of my laptop. Python's completely occupied. No. What the hell happened? Memory limit. What? How? I don't understand. Wait, what? This is stupid. Very stupid. Wait, hold on. It's not valid. Wait, hold a second. Okay, there are some wrongs, I know. Okay, that was good. And let's just print dp nums j. Huh? What the hell? Oh, I see. I see. It should be position. God, man. Randoms. Shouldn't be value, it should be positions. DPI. DPJ. Okay. Oh, there's no values. For v in dp, if v. Okay. This is a little bit need to figure out. The hell is that? So everything dp this is gonna be, and then we put things in, right? And then dpi is gonna be a list. So it's gonna be a list of list of list. Lord. Oh, chain. God. I don't know how to do chain anymore. So each one is a list of list, right? And this one we want to chain it. So chain, I'm just guessing. Nah. Chain is not defined from it tools port chain. Nah. Chain again. I'm just, I have no idea what I'm doing right now. Nah. Alright, how do you use chain? Okay, chain. Turn this and this into this. I have a list, right? And then of list. So I can chain it. So hold on. Maybe I can chain DP. No, chain this DP. Will be this, and then it will break. Right, it will be a list of lists. So I think if I list this thing, it shall be correct. Yeah, that's the one. That's the one. Nah, I can still run Python, even though it's like 100% right now. I've done this before. And I got a wrong answer. Lordy. I'm not expecting this to happen. I think I probably used the cheap shot. What is the expected? I see. Good call. Yep. Have these ones. I don't know. Maybe I should use a cheap shot. I don't want to use the cheap shot. I want to directly figure it out. And I just have repeats. That's the thing. I have repeats. How do I handle repeats? Because I have 4 ones, right? So 1. Take 1. So here, I'll take this, which is 1. I take another 1. I mean, an easier example would be 1, 1, 1. Okay. If I do 1, 1, 1, should be 1, 1, and 1, 1, 1. That is not correct. Yeah. 1. So when this one comes in, I go this. I already seen this one. Alright, no, I haven't seen this one yet. So I'll add it. But that's not true because I already seen it. seen by. Not in seen should be nums I. Alright. Have this been seen? If not, then we say seen nums I. Yep, so seen I equals set JK means number I has encountered J and K before. So with that, now working. Now working. I guess there's no other way. Why? Yep. Screw it. Screw it. We're doing it. Screw this. I don't care. Can just say res fj, this larger than this, right? And then res set dot add nums I nums j. Let's do can we do this? A sequence in this, if sequence not in res set, okay, then then we will need to add every single one. Nah, I don't like it. I don't like it. I do not like it. That's just stupid. This. Doubles equals s nums I nums j. Right. If double is not in res set dot add this double and dpi dot append double. And then for sequence it is, if sequence not in, then we'll do this plus, and I will return list tuple for tuple in rest set. Huh? What? Alright, I'm not sure. Yeah, that should be right. Num plus sequence. Oh, I forgot to add. That's weird. Okay. Oh, I was wrong. New sequence. If new sequence not in rest set. New sequence. New sequence. In that case, I do think we can do it this way. Alright. Then we don't need this. Just say this. New sequence. There we go. Yep. Yeah, I don't know. I don't like the idea of using set. Pretty sure there's a better way. I don't know. Set feels like cheating. But I mean, given this, it's so small, right? The size is so small. Maybe set is the way to go. Who knows? 491. I initially did not want to use set, but couldn't figure out a way without set to remove duplicates. Hold on, I need to do some housekeeping for the things. 139, that's the minutes. Okay. Yeah, simple housekeeping. Simple housekeeping. Oh, this is 1 minute. Okay, this one's done. 1 minute. Now we're tuning this thing. It'll take 18 minutes. Okay. I'll let it tune. 18 minutes. Okay, so let's see the previous solution. I was chaining DP. There's no set. I was checking for dupe. Back then I was checking for dupe. Oh. Oh, when you find a dupe, then you just escape. We only do it once. Gotcha. Oh yeah, this actually makes sense. This actually makes sense. Oh, we just backtracking. Yeah, not interested in backtracking. But that's the solution to you just stop because I already handled. So we have everything there already. You keep going, you will just do exactly the same thing. Okay, here is how to not use set. We just stop when we encounter a dupe. Because if we keep moving on, it will be the same. We'll repeat the same situation, right? Situation. For example, say we have 1 1 1 1 1 1 1, right? At position 1, we already handle. We have already handled the situation of 3 1s. Thus, at position 0, we shall not progress past position 1, because if we do, we will be in the same situation of 3 1s. Okay, that actually is better. So DP for this in nums, I like that. And then what we can do is for I in range nums -2 -1 -1. Okay. J in range I +1 to line nums if nums j is larger equal to nums I, okay, then, well, I think if it's larger than, then we get everything plus that. Right? Hold on, let me think. Oh, we just get everything. But how do you handle like 4, 6, 4, 6? We'll have 4, 6, and we'll have 4, 6 again. Just everything under this. It doesn't right. It's not right. It's not right. But if we only do this larger than, okay, so this will be 4 something something, right? Then the next one, if it's larger than that, I can take it, right? And for this, because I only look at this one, if I go hit something the same, then I stop. I see. Okay. So we will do this. I don't have anything. I just have 6, 6. 4, 5, 6, 6. But what about 4, 6? That's a good question. What about it? Unless I don't care about it. Wait, how do we resolve this? Yeah, this is what I'm afraid of. This 4, 6, 4, 6 situation. Alright, I have this. I can say, okay, I have this 4. I do 4, 6. And the 6, I go here, I do 6, 6, and I stop. Okay, I have 4, 6, and 6, 6. And here, I go here, I have 4, 6 again. But we cannot have 4, 6 again. So we're saying when we do this, only the first one has. But if the first one only the first one can do it. So everything I do it, this I can do it, but this I don't do it. But how do you know to not do it? Well, you know to not do it because as you go, you find something already. So we do that at the end. We do that at the end. Makes sense. So if it is larger than this, so all we do is we do everything. Okay. We say a sequence in dpj dpi dot append nums I, right, plus sequence. Blah blah blah. So we add everything. Now we say if nums j is equal to nums I, that's when we break. Okay, break. Else, if we can figure out everything and we don't break, then what we do is we need to add by itself because that will be the first time it appears. So we say dpi dot append by itself. By itself. No, why do I do this by myself? No, I basically, is I go, right? Oh yeah, I just do it by myself. I add myself to this. And if I do this, I might be able to start with this. And then now I return well, chain dp, and then we say v for v in this if len v is larger than 1. Let's see, solution 2. Yep. I think this one is right. There we go. That's even better. But I think it's slightly different from this one. Oh no, this is not the solution I like. This is the solution I like. Oh, it's the same. Oh wow, it's exactly the same. Good for me. I was able to figure out. I was, having some issues. Alright, we're having some issues. I can extend. Same thing. Yeah, break else. Yep. Good question. That's a good question. Yeah, you hit the same, then you stop and thought about it. But it's okay. It's okay. Alright. So we're done with this. We are done with this. Alright, back to the old struggle. Okay, we have a test case we can try. Okay, let's do this. We have robot at -9, -7, -6, 3, and Lord -20. And we have factories at 1, -15, and -17. Okay, the answer shall be 28 -32. So if we draw this, if the role is going to be robot, so we're gonna say have 1, 2, 3, 4, 5. So 0, 1, 2, no, 1, 2, 3, 4, 5. 5 robot. Okay. We have 3 locations. 0, 1, 2. Okay. So when the 0th robot comes in, which is minus 20, I want to find a place, and then we have only one location. So actually this is minus 20, and we also need a state, right? Okay, so we have minus 20, minus 9, minus 7, minus 6, and 3. Would be minus 17, minus 15, and 1. So it'd be the array of 3 values. Okay, so with a 0 and a 0, 0 robot with the first factory, then the first factory we have 2 capacities, right? So initial state you know what, let's do this again. We need 1, 2, 3, 4, 5. 1, 2. Okay. 17 minus 15, 1. I was actually gonna need one more. Okay. And there we have minus 20, minus 9, minus 7, minus 6, and minus 3. So the state, all of this, the state should be the same. Oh, the capacity. Yeah. Capacity. Yeah, it's fine, the capacity. The capacity is what? 215. Okay. 215. 215. 215. Okay, so first one with the first. I check. Right? I have 2 capacities I can do. So the distance, right? The distance, ABS, the distance will be 3. And this will be 115. The next one, so one with 2. So one with 2, the minimum shall also be 3, right? Because that will be 5, so the minimum with 2 will be 3, and it's still the same, 115. That will be 3 and a 115. Okay. All right. Now 2 robots. 2 robots with 1. So 2 robots, 1. So I can only just try, because I only have 1. I need to try to get this 1. Ask if it still has capacity. And all this should be infinity, so we don't choose this, right? It doesn't even matter. So these should all be infinity. This is, yeah, that's no. We have no capacity. Things all should be infinity. So what we need to ask is this. Can we do that? No. Right, we cannot do that. Which means this go over this, and then this try to get this. No. Or get this, which is 1 get 1, and this one will get to, yeah, just this one get to the current one. Can we do that? Yes, we can. Yes, we can. We can do that. So minus 9 2 minus 17 is what? 8. Yeah, 8. So that'll be 11. And it will be 0, 1, 5. So basically both are here. Now we have 2. Okay. And of course, another situation is I'm going to try to, yeah, but that doesn't go. Okay, now we have 2 factories and 2 robots. So situation 1 is, I say, 1 factory, 1 robot. And the second one, we want to go to the new one, right? Would that work? Second one, go to the new one. If the second one go to the new one, then we will have, yes, we have capacity. So we have 1, 0, would be 1, 0, 5. And that would be 6, so it would be 9, right? So in this situation. Or we go, no, that's that. Or we go this. This is the first one go to both, and the second one want to go here as well. And the second one want to go here is going to be the same as 9, 1, 0, 5, because the states are the same. Or we can say both are going to the first. Okay, we're both going to the first, and when nobody takes this one, so in that case we're going to take 11, 0, 1, 5. So in this, the best case should be 9, 1, 0, 5. Okay, now we have 3. Again, we try to say this is 2 robots taken, no, 1 robot taken 2. Yeah, 1 robot taken 2, right? If 1 robot taken 2 and the third robot, I say directly take the third one. So in that case, it's going to be 8. So that will be 11, 1, 0, 5. Second case, 1 robot taken 3. 1 robot taken 3. And this 1 robot taken 3. And then I have to go 1 by 1. Right? One robot taken 3. I have to go 1 by 1. If 1 robot taken 3, then I have to go 1 by 1 to see which one give me the best. And then this one's 8, we'll give 11. And this one's 9. So be 9, 1, 0, 5 again. And a third robot coming in. Okay. We're gonna try 3 robot on the 1. That's not possible. So infinity. Okay, 3 robot on 2. So what we can do is 3 robot into 2 robot on 1. Okay, 2 robot on 1, and a third robot on the second one. in this case is infinity because the second one doesn't have capacity. Okay, so that's not happening. Hold on, again. 2 robots on 1. No, we have 2 robots on 1. That's 2 robots on 1, and this robot on the second one. I do. I have 10. I have 21. 21 with 0, 0, 5. Now, this case. This case is 2 robots on 2. Okay, 2 robots on 2 already. And the third one needs to go 1 by 1. Okay, so third one, try the first one. And try the first one is 10, it's 19. Oh, no. That's not 21. I'm taking this one. Minus 7, that's 8. It's 19. Second one is also 19, 0, 0, 5. Okay. I can take second one, and I cannot take second one. Okay, how about this one? This one is... Third, I would take 1. Not possible. So it's 19, 0, 0, 5. Okay, now 3. So 2 robots take 2. Third robot take the third one. That's possible. That's gonna be 8, 17. 1, 0, 4. Or here, 2 robots take 3, and the third robot has to try 1 by 1. Try the first one is 19. Try the third one, so that's 17. 1, 0, 4. Okay, fourth robot coming in. First one, impossible. Second one, first 3, try this, no good. So first get all of them, and this has to try. The only possibility is this, which is 11. No. Yes. Oh, 9. 9 plus 9 is 28. So we got 28, 0, 0, 5. The last one, I got 3. Oh no, that's not possible, because it's 2. Shoot, it's infinity. It's the last one. Previous, we can try this. Right? 3 robots with 2, and the last one with this, with 7. So we have 26, 0, 0, 4. Or this is infinity, or this. Then we try the first one, will be 11, will be 28. That's actually worse. This one cannot go with the last one. Last one is going to be 7, so 24. So this one will have 24. 1, 0, 3. This is impossible. This is impossible. And the last one. The last one. Can do the first one, but that's too big. Here's the last one, so 1, 0, 2. 26. What? I got 26 now. That's not right. Okay, so hold on. The first one go to the first. How about the second one? Second one go to the second, third one go to 1, fourth one go to 1, fifth one go to 1. It could be a calculation error. This is 3. This is 6. No, it's 8. 7, 2, 9. Huh? Minus 20, minus 9, minus 7, 6, and 3. Position is 1, minus 15, or minus 17. Oh, I got it wrong. Minus 17 is 5. But anyway, I think this one will work. I think I need to redo this thing. All right, how do we redo this thing? How about the start? The start is going to be, these are not possible, right? And then, how about this? This shall be 0. Which means the first one is 0 initial state. N, what's N? N is number of factory. This is correct. And this is correct. That's fine. And for I is 1 to this. I is also correct. And actually I don't have I minus 1. I do have I minus 1. That is now Rao. That's I is just M. That's fine. I can just go M. Okay. Then what do we need? I have a temp. Temp is to build a current one. So the start. Yes, that's fine. Start is fine. And for J, J has to be this way. Okay. Option 1 is J's robot uses previous. Yes, so J's robot uses the previous. The ith robot will use the previous machine, so it's J minus 1. Temp J minus 1, yes. So basically that's one of them. Yes, okay. Option 2, ith robot uses J's machine. So it should be the diagonal, right? That's the diagonal one. So it's the DP, which is the previous row, J minus 1. That is true. Now we get a state. I think we have some issue here. I think the initial state. This initial state should be empty because we cannot take it. That's fine. That's really actually fine because D2 diagonals be infinity. So that's actually okay. It doesn't really matter. So we say if this is the machine, right? And then the state. We'll try to take the first one. We say if this is larger than 0, then the D2 will plus equal to previous D2 and current robot. That's just the robot I minus previous. That's, I think that's correct. And then otherwise this. Now I'm going to use every single one. Is going to be DPJ, the one above us. Right, the one above us. So we use everything, and then the new one comes in, we have to check every single one. Okay, so we have to check every single one, and we say target. This is what we're gonna get, right? And the current distance, so we just set to infinity. So we're gonna set from k from j minus 1. So we just want to go through all of them from j all the way down. Every single one. We'll try every single one. That's fine. So yeah, I mean, if we don't care, we can just go from the start. That's perfectly fine by me. So I'll just go to j, right? Yeah. And then for each one, we're gonna say this dy will equal to this if we have capacity. Otherwise, d is gonna be infinity. And then if d is smaller than this, current will be this, and then let's just go through everything. It's simpler. And once we're done, d3 will plus equal to this, and then now I have three situations. We say if d1 is the smallest, or we prefer d1 is the smallest. That's what we prefer. Right, d1 is smaller equal to d2, and d1 is smaller equal to d3, which basically saying if we can save, right, we'll save it, then we'll just use this. If d2, which means I will use only one, right, and d2 is smaller than d1, and d2 is the smallest. Then, yeah, the thing is, I probably have to reorganize this. Hold on. Let me try this. I think I got it wrong. I got this as 2. And I got this as 1. I got this as 5. Do I got this right? Ah, God. I have to analyze it again. Lord. Anyway, we just keep analyzing, right? If the d2 is, I'm just trying to get this one, right? Hold on. D2 is diagonal. D2 is diagonal. Yes, D2 is diagonal. And we try to see if D2 and D3 are the same and they're smaller than D1. So we shall take D2 and J minus 1 is the index. Target J is also the index of the factory, right? We say if this larger equal to, then I take as D2. Shouldn't this be smaller or equal to? Because D2, D3 are the same. We favor D2 when its thing is smaller than target, smaller than D3's thing. So we push more to the left. Then we do this. We decrement it and we do this. Otherwise, we take D3. And if D2 is smaller and D2 is all smaller, then we do this. If D3 is all smaller, then we do this. And we do this and we do this. Okay, let's try. Nope. Still wrong. Okay, we have to reanalyze this, unfortunately. Yeah, I got it wrong. It's alright, it's alright. I actually want to... Okay, let's redo this. No biggie. I've been through this before. Yeah, I just got it wrong. It's okay. Okay, we need 6 rows. 3, 4, 5, 6. 3 columns, 4 columns. Okay. Pay attention. We got minus 20, minus 9, minus 7, minus 6, and 3. And we have on top minus 17, minus 15, and 1. And the capacity, and these are infinite. Don't care. And the capacity is going to be minus 17 is 5. Minus 15 is 1. 5, 1, 2. Okay. 5, 1, 2. 5, 1, 2. Okay. First row is going to be 3, 4, 1, 2. Yes. 3, 4, 1, 2. 3, 4, 1, 2. That is correct. We can actually yeah, we can do this. Actually, I'm gonna do this. Minus 20, minus 9, minus 7, minus 6, 3, right? Again, remove this. Remove this. Aha, you know what I'm doing. Remove this. See how many were correct? Ah, shoot. Three, 4, 5. I don't think we'll be all wrong. Oh, internet. Oh my god. This is 2. This is 5. Unbelievable. Three, 9, 17, 24. It's the last one, which means up until 24 we're all correct. It's the last one. What happened in the last one? I mean, we presume that everything is okay. So in the last one is 3. Right? We don't have anything that adds up to 28. Which means something must be wrong previously. Actually, it should be the smallest among these. I just realized. But even if the smallest, like it should be the smallest of the last one. Should be the minimum, right? Should be the minimum of dp. Distance for d in dp. Yeah, should be the minimum. Shall be the minimum. It's the same, because these are the minimum. Okay. I mean, first one I have no question. The second one, diagonal doesn't work, so we try this to do the same. Yes, and that's gonna be 8. Right? Should be 11. 3, 1, 2. Here. Now we have 2. Okay. So we can say the previous take this, so I need to take this. So that's be 6. That'll be 9. 4, 0, 2. Or that's 11. Or we take this. Then we go one by one. We're going to take the first. Just give me 8, so it's 11. So that should be 9. 4, 0, 2. How about this one? 3. So we either take this or I take this one. It'll be 8. That'll be 10. So it'll be 13. Four, 1, 1. Right, or one taking this, and I have to go one by one. 8, 6. So it is 6. So 9. So it should be 9, 4, 0, 2. Yeah. Next, the first one, that's a 21. 2, 1, 2. 8. So it's 19. 3, 0, 2. Then we will have 19, 3, 0, 2. So it should be 19, 3, 0, 2. And this one, 6. Now 8, 17. 4, 0, 1. 19. 8. No, we cannot do. Yep, 17. 4, 0, 1. 11, 32. 9, 30. 11, 30. cannot take this. So it'll be 30. Okay, this 7, 26. I see we have a 26. 301. That'll be 11. That'll be 28. Wait, no, hold on. If we take this, 7, 26. Take this, 9, 26. Yes. We'll take this. Be 6, 7, 24, 3, 4, 0, 0. So we choose 24, 4, 0, 0. That's what the problem is. I can choose 4, 0, 0 or 26, 3, 0, 1. So when the last one comes in, now the first one is going to be horrendous. 52, right? 0, 1, 2. Second one is 18, 50, right? Oh. No, you cannot do. You can't take it. Oh, you can. 1, 0, 2. And the last one. Oh, if we do this, take the first. That's 20. It's 50. Or yeah. And the last one, you're gonna do 32, right? So it'll be 32, 2, 0, 1. Or take this. I'm gonna take the first. Will be 20. So 54. 3, 0, 0. And we cannot take this. So that's why it's 32. But we have another option, which is 26, 3, 0, 1. If we do 26, 0, 0, 0, 1, we can take the first. That'll be 56, 2, 0, 1. Okay. And then second cannot, and we can take the last one. That'll be 28, 3, 0, 0. So it should be 28. I see the problem. It should be more than one. I should put all the situation in it. And granted, this only have one situations. Damn it. Okay. Let's delay it until tomorrow because it's late. I know. So basically, this. Oh my god. It has to be a list of lists. I have to put another list in it. Oh my god. Oh my god. And then we just pick. Yeah, like we have to save all possible situations. If we have multiple situations, we have to save all of them. Holy moly. No wonder it's only 100. All right, we'll do this again. But does that mean like, because this is all situation as well in this case. If I have multiple in here, we gotta do multiple here. Wow. How? And basically we are not, like, if it's impossible then we don't record it, but as long as it's possible we need to put it in there. Interesting thought. Maybe, you know what, it's actually gonna make it easier. We don't have to make any choices. The problem is we're making choices here, but we shouldn't make any choice. We just save up all the states, every single thing, all the states. And whenever we need to make changes to the state, we'll copy it. Gotcha.